Hi everyone, welcome again to a new YouTube video. My name is Juan Pablo Solano, and in this time we will talk about BGP, okay? And in this series of videos also we will talk about different BGP attributes. One of them that we will mention today is called local preference. Local preference, as you might know, is in the second level of the BGP best path selection for Cisco devices. First is the weight, right? Local preference is second one. And we will use local preference in this feature to prefer certain prefixes to choose one path and for other certain prefixes to choose another path. Okay, so BGP have different attributes that we can play with. Local preference essentially influence the outgoing traffic from the device perspective. So if we want to reach to a specific prefixes, we might need to use local preference for preferring a specific exit points for particular prefixes. Okay, so that's the main goal of the lab. And for this, we have this network that you can see here. We have BGP Autonomous System 100, 200, and 300. In this Autonomous System 100, we have basically IVGP sessions. So these are IVGP sessions. IVGP sessions here. We have here IVGP sessions, and here as well. IVGP sessions. Then the ASPR ISP1 have EVGP sessions with another autonomous systems. So EVGP sessions, and also to the autonomous system 300 we have EVGP sessions, and also from here we have EVGP sessions. Okay, so this is the lab topology. ISP2 is sending prefixes 11, 11, 11/32 and 21, 21, 21/32 to ISP1. ISP3 is sending the prefixes 12, 12, 12/32 and 22, 22, 22/32 to ISP1. By default, ISP1 is receiving those prefixes from both providers, and there are no any modifications in the BGP attributes. But what we will do is we will just grab those prefixes received from ISP2, and we will ensure that ISP1 will always prefer ISP2 for reaching out to those prefixes here. Okay. Also, we will configure ISP1 to prefer to reach those prefixes 12, 12, 12, 12, and 22 by ISP3 always. Okay. So in real case scenario, that type of preference for balancing the traffic, the outgoing traffic, is quite common. Okay, obviously in my lab, the ISP2 is forwarding those prefixes 21 and 11 directly to ISP1, and ISP3 is forwarding those two prefixes as well directly to ISP1. So there might not be chance that ISP1, even if we don't modify the local preference, that ISP1 will prefer to reach these prefixes by ISP2, ISP3, because obviously it's directly connected. But in real case scenarios, those prefixes are probably behind of both ISPs by many other ISPs in the middle. Those prefixes are being received, and we don't know what preference ISP1 will take for reaching out those prefixes. It might take ISP2, it might take ISP3. Maybe the prefix being advertised by ISP2 has a, let's say these two prefixes have a long path, because those prefixes have been in many providers' network before, and the ISP3 advertised the same prefixes 21 and 11 with a short path. So then ISP1 will prefer ISP3 because it has short path instead of going to ISP2. Okay, so in real case scenario, local preference is being used especially in the border devices that we have access to our internet connection. Okay, so it's a very good protocol to be used for our outgoing traffic, for manipulate outgoing traffic, and this is part of traffic engineering in BGP. And as you know, BGP probably is the best protocol to perform traffic engineering for reaching certain prefixes. So let's go with the lab. We will go to ISP1 ASBR and we will check what we are receiving from both neighbors. Okay. So here we are receiving ISP1 basically these 5 prefixes, as you could see, 11 and 21 and 12 and 22. For now we will focus only on those prefixes. If we take a look on 11, 11, 11, what we have in our BGP table, we basically have only one next hop, which is 200.1.1.1.10. This is the connection to the ISP2. We are not receiving the same prefix to ISP3. So let's take a look what is the next hop for 12, 12, 12, 12. For the prefix 12, 12, 12, the next hop is 201.2.10. So it's basically ISP3. But as you can see, the local preference is the same value here and the same value here. What we will do is we will configure ISP1 to match specifically 11 and 21 and set a local preference of 200, match the prefix 12 and 22 as well, and to put a local preference 200, but to put the local preference 200 for 12 and 22 towards ISP3 and for 11 and 21 towards ISP2. So for that, we need to first create a prefix set. So we create prefix set, we can say prefix from ISP2, and here we can add the prefix 11, 11, 11, and also the prefix 21, 21, 21 slash 30, 22. Okay, so 21, 21, 21 slash 20, 32. So here we have the prefix set from ISP2. I will configure as well prefix set from ISP3. So here, here I will just put the ISP3, and here we'll put 12, 12, 12, 12 slash 32, and also 22, 22, 22, 22 slash 30, 32. So here already I created the 2 prefix sets to match the prefixes from one side and from the other. Now I will create the route policy from ISP2, and here I will configure the route policy. In IOSXR, now I am running a XRB, so there is a different way to configure route policies, or what we normally call in IOSXE roadmap, and this is by using the route policy. Okay, so the way that we configure and apply a local preference is by using the if destination. Here we put the if destination in prefix set from ISP2, then set local preference 200, else pass. Okay, and end if. So let's review what we configure in the route policy. I basically match the prefixes from ISP2, the one that I need to receive from ISP2, which is 11 and 12 and 21, sorry, and I put a higher local preference in here. Okay, now I will create another route policy which will say from ISP3, and here I will put if destination in prefix from ISP3, then set local preference 200, else pass and if. Okay, so here basically is all my configuration that I need for influence the out-of-band traffic from the point of view of ISP1. Okay, so the second route policy basically is to ISP3, and here I basically match the prefix set from ISP3 that I want, which is 12 and 22, and to that prefix set I will put a local preference of 200. Okay, so I have configured both route policies. I will just go into BGP. So basically, let me check which prefix, which BGP I have. So BGP 100, router BGP 100, neighbor, and I go under the neighbor to ISP2, and here I basically just put the address family and route policy from ISP2 in. I need to influence the incoming route policy because I am receiving the prefixes and I want to apply the local preference. And the same to the neighbor for ISP3, basically address family IP for unicast, route policy from ISP3 in. And this is my configuration that I have applied. I configure BGP as well towards ISP2. I put the route policy from ISP2 to modify the local preference for the 11 and 21. And also I enter into ISP3 and I configure a route policy to modify the prefix BGP attributes for 12 and 22. So I just commit as we normally do in IOSXR. And if I type again the show BGP IPv4, here I type again, here it got updated. Okay, so 11, for example, from ISP2 I received now with a local preference 200, 12 I receive from ISP3 with a local preference 200 as well. 21 is the same and 22 is the same. If I just do a last verification 11.11.11/32, I see that the local preference is 200 for ISP2 for the 11.11.11, and for 12.12.12 I check and the local preference is as well 200, but is from ISP3. And this is a way that we can basically manipulate our outgoing traffic for specific prefixes. Okay, sometimes we can match, as you could see here, the prefix set by prefix level. For example, if I just take one prefix set, I can match by prefix level, or I can match the prefixes in the raw policy. In this case, the raw policy from ISP3. I can match for prefix level, or I can also match by community, for example. Instead of defining every prefix, I can just put a community if the prefix is marked with a community. That also can be done. In my case, I just did simple prefix matching. Okay, this is a way again that we can apply local preference and we can influence our outgoing traffic. Thank you very much for watching. The next video will talk about the next BGP attribute which influence the out-of-band traffic, and see you in the next video. Thanks a lot.